Go. Hello, we're the Penguineers, team number 11454. And we're gonna make a video to kind of just create a structured roadmap for an engineering design process for new FTC teams and experienced ones. This is what we do, although feel free to change any part of it that you might not like or might not work as well for your team. So we have a couple kind of major steps. We have 5 major steps and 4 on this list, and we're gonna kind of explain the 5th one. Is a little more nuanced, so we didn't have a kind of structured entry into it. And so what we do is initially we start with the ConOps, or a concept of operations if you're not familiar, which is kind of the entry or the broad heading as to what we're doing, and then the exit criteria or the criteria we came up with in order to pass this stage. So the ConOps should tell a story about our scoring strategy. So kind of what it would be is we would have a kind of like a chart or a morph chart, and what it would have is it would have our robot functions and then a series of potential ways to get each of these functions done. So let's say this year with the specimens, we want to pick up specimens. And one way we could do that is, and then we have option 1, option 2, and option 3. So one option could be maybe you have a claw. Another, you have an active intake like a windmill. And I didn't really think this through that well, so I off the top of my head, I can't come up with the third, but you could see kind of where this is going. So essentially what we do from there is we kind of lay out a bunch of broad variety of ways to do everything. So you can expand this and extrapolate it from picking up to things like picking up, scoring, hanging, like outtake, intake, delivery, all of these different functions. And then we give as many options as possible, kind of laying the groundwork for a variety of thought processes and designs in the way we do our whatever robot. So with that, we give each of the members of the team, and they can form sub-teams too, or do it completely independently. What we'll have them do is kind of format a robot, picking different categories from this morph chart with all the various functions. So maybe for picking up, they choose a claw. When they want to hang, they choose a slide, or when they want to outtake, they use an arm. So, but you could obviously choose any variety of combinations, and inevitably you're going to have different people do different things and show their preferences. So then we move up. If everything's okay on this and we pass it through the coaches and it kind of tells us this full story about a robot strategy, so what we do is we kind of move forward towards this next category. The next category is probably the most intensive of them all and takes the most time, but it's also the most worthwhile. Because right here we kind of have a broad overview of what we want to do with the robot, but here is where we get into the semantics and the very specific details. So this part is CAD, so or computer-aided design. You can do this in SolidWorks, you could do this in Onshape, you could do this in Autodesk, but personally we chose SolidWorks. So what we do is we create a very, very thorough CAD design, and the CAD design would feature all of the various components to be a multi-part, multi-assembly that would feature every single component we chose from the morph chart. So for instance, our CAD design, we had this worm gear and slide system, we had a custom claw we made, and we had the Go Build a chassis we used. And we had all of these various features that we would actually feature on the robot on the CAD design. And it should be as thorough as possible, although if mid-season you need to change something, that should be an opportunity as well because of the time constraints. And once we do this, we'll check off that it actually shows everything, every circle, every option we chose, and our entire configuration on the ConOps. And yeah, that's really about it for the CAD.
Hello, I'm Alex, and I'm going to be going over bill of materials and virtual inspection. So moving straight into bill of materials, right after our CAD model gets finalized and gets reviewed from the entire team, and everybody says it's okay, and they like the design, we're going to go to constructing a bill of materials from the CAD model. Now usually this step isn't too hard for us, as we just look at the CAD model, which is intensively detailed in order to see what we need to buy. Whenever we're constructing our bill of materials, we want to make it easy for our coaches to order the parts. So be sure to include vendor, the category number, and the cost of ordering and shipping design. This is very important when doing proper budgeting for your team, and you want to make sure that you're really stringent on this part, because a lacking bill of materials can lead to poor funding, management, and overall might lead to a subpar robot build. After we get the bill of materials sent in, we want to make sure that before we purchase all the parts, that our robot actually works as designed. So we will go through a virtual inspection process in which we will take the inspection list from the game manual and check off every single dot, making sure that we apply to all the FTC game rules and that we're properly within the constraints given to us. So some specific things that we highlight here, make sure that we're in the 18 by 18 by 18 cube, counting the number of motors and servos in our robot as well. CAD models help us a lot when doing this step because without those, we won't be able to see what is going on with our game and how our robot's working with itself and the assemblies within it. That way you can do things such as determining degrees of freedom and a bunch of other stuff that CAD software allows for whenever designing robots.
All right, so once we have all these general things, we have this kind of fifth and broader step. So the big thing about this is we have to actually make sure our coaches know that our model and things will be successful. So what we're actually gonna do is step number 5, which is a presentation. So basically, what we are going to do is we're gonna put together a slides presentation or a PowerPoint or a Keynote if you have a Mac. And what this is it'll go over, it'll have screenshots from SolidWorks or Onshape of your CAD model. It'll have the ConOps on there. And it'll basically just put together, collate all of this information from the entry and exit criteria onto a streamlined document like a slides. So we go in, we present that, we ask the coaches for feedback and questions, and what they'll kind of do is either if A, it's really successful and it goes through everything perfectly, everything's interrelated, intertwines, it passes all the inspection, the bill of materials is perfect, we would be able to release funds, in which is probably the most important part, which is then we authorize our funds and we can actually buy these parts if we need them and everything like that. And if not, well, the coaches will kind of determine in the process where something went wrong or where like a process kind of failed, and then they can either return us to any of these 3 different processes and tell us to modify something they don't really approve of or they think is the best, most optimal way of going about it. So one of the things you might be wondering is why would we do this? And there are a couple of things. So the big advantage is kind of knowing where like everything is kind of more structured and you kind of know what everything actually is going to fit together and work. So in the past, one of the problems we ran into, and it's both that it comes with advantages and disadvantages, is we would prototype everything actually before. So we build a quick prototype, kind of modify it a little and tune it towards the game designs and our general needs for the year. So this was helpful in getting us a quick design that could work in terms of like the immediate area and the we would always have a build before the first scrimmage. We'd always be prepared. We always made a weekend build video and everything like that. But as the season progressed, we found it really hard to like modify our robot to what we actually wanted. Our initial robot often wasn't the most optimal way of doing things because we just kind of sat down, watched the game video, and what we did was we talked about it for about 5 minutes and then we just started building. But like this year we kind of changed that, and since we put in so much thought and process, we really had the opportunity to sit through and think every single idea, and that's really helpful in terms of actually making sure our design's optimal. And that was one of the things I thought was good. A couple things in this too that are really nice is CAD software makes it really, really easy to know what you need. So this is probably the most important step, and if you take anything away from this, I would say try and CAD out your robot before you actually get it done. One thing is nice is it kind of ties together all these other parts. Like you do the virtual inspection in the CAD, the bill of materials comes from the CAD, because if you get down the STL files from GoBuilder, you know the exact files you're getting, how many of them, it's all detailed on SolidWorks, or if another software, I'd assume the same kind of thing. And it tells you everything you need, like how important, like where you could get it. It tells the maker, the part number, and that's just all in your CAD automatically, and you kind of don't have to research anything and bring it up. Also, the CAD is nice too, because once you CAD it out, you know every part you need, and although you might subject to change after you're actually testing it, because nothing really can substitute actually testing your robot. It's more kind of structured to the way you need. So you know basically all the parts you need. You know kind of everything you want. So that's really nice. So I mean, if you're asking why you do this, it just makes it more structured, more easy, and better for the long run, although it might sacrifice some things in the short run. And that's about it for our design criteria and video. If you have any questions, put them down in the comments. reach out to us on. You can email us. We have a Twitter, and we also have an Instagram and a website as well. So thank you guys for watching, and that is kind of our design criteria video.